Hey there, and welcome to Decoding the Digital Lab with CSols, the podcast that explores emerging technologies and offers insights. I'm your host, Megan Pettyjohn, and in this series, we're exploring exciting new ways to make your digital lab work smarter. In today's episode, we'll be unpacking the real-world challenges of integrating AI into regulatory lab workflows, from data integrity and privacy to validation and intellectual property. With me today is Alex Chronis, a senior informatics consultant with deep insights on AI in the regulatory space. Hi, Alex. Great to have you on the show.
Hi, Megan. Thanks for having me. So it's a great time to be in informatics, and AI is certainly at the forefront of many of conversations I've been having.
It truly is. Before we dive too deep into the AI world, for listeners who might be a little bit newer to this discussion, can you quickly define what we mean by LIMS, and then in simple terms, what AI is in this context?
Yeah, sure thing. So a LIMS, or a laboratory information management system, is essentially the digital backbone of a lab. And for other business sectors like warehousing, R&D, and quality. So it manages samples, experiments, results, instruments, and data overall, ensuring everything is tracked and traceable. So it's all about organizing and streamlining the lab's operations while being compliant to regulatory requirements as well. Now, in respect to AI, in our context, this isn't about sentient robots and control over humanity. Instead, it's really about intelligent software tools that augments human capabilities. So, for example, AI can provide advanced pattern recognition and prediction, allowing for cognitive computing to perform tasks that traditionally required human intelligence.
That's a perfect way to put it. Intelligent tools augmenting human capabilities. And of course, the general connection here is that AI thrives on data, and lab informatics systems like LIMS are precisely where all that valuable lab data lives and is managed.
Yeah, and the more organized and robust your informatics foundation is, the more effectively you can use your AI tool.
So let's talk about some real world applications. From what you've seen in the industry, where is AI currently being used in the labs? Can you give us some concrete examples?
We're seeing innovative applications across various lab types and functions for companies that are already truly digital and or going towards more digitization. So, for instance, intelligent alerts are becoming more common. AI systems can monitor instrument data and in real time and can flag anomalies and potential issues before they escalate, saving you time and preventing costly issues down the road. We're also seeing more predictive modeling where AI can analyze historical data to forecast things like potential upcoming instrument maintenance failures, where sensors could fail over time, or even seasonal trends and external factors that may impact the samples, both of which help the lab plan more effectively, operate more efficiently, and then reduce the potential for risk down the pike.
Can you give me an example of an external factor that could be used in predictive modeling?
Yeah, sure thing. So for manufacturing, I've seen clients in specific locations having challenges with humidity affecting testing results. Predictive modeling can provide metrics on estimated date ranges when the environment could be most heavily impacted, which provides the lab insight and allows them to sort of adjust, have the opportunity to adjust calculations or even the physical laboratory itself.
Those intelligent alerts and predictive models sound like a game changer for efficiency, allowing labs to be much more proactive. It's not just about preventing problems, but also making data more accessible and insightful. For instance, in a previous episode, when I was speaking to Alec about the natural language processing, or NLP, capabilities being integrated into LIMS and ELN systems. It allows scientists to simply type questions in plain language rather than needing to understand the complex database queries, significantly speeding up data retrieval for reports or specific analysis.
Yeah, and that in fact reminds me of the Lab Twin application, as it uses voice activated commands to drive laboratory processing hands free, directly at the bench.
I forgot about that. That's right.
Yep. So, and that's a huge step forward, right, for lab personnel. So AI is also powering smarter searching and reporting, right? So imagine being able to ask your LIMS or ELN a plain language question. This could be a natural, as we call it, a natural language query, for instance. Hey, Gemini, hey, Siri, show me all of the QC results across all the batches for product X from the last month and where they were out of specification. So AI can understand what I'm saying and pull together the relevant data together much faster than traditional methods like developing SQL code or, of course, my tried and true, an Excel sheet. So it can pull all that together for you quite easily.
What about trend reporting and metrics?
Sure. When it comes to metrics, AI can automate the generation of summaries, identify key trends, and even help visualize the complex data sets that you may have. So this can increase the speed of report creation dramatically with very little effort from the user.
That sounds great. It'll free up a lot of scientists from tedious data wrangling and let them focus on the science itself.
Well, this also gives users that aren't developers more control and confidence in creating these types of reports for themselves and for their departments, right? But this also reduces the need for expensive development resources that you may need.
But of course, with every powerful new technology, especially in the regulated environments, comes a new set of considerations. As labs increasingly integrate AI into their workflows, they need to be acutely aware of potential compliance risks. So, where do these risks typically emerge?
Right. So that's the $1 million question, right? Especially with in GXP environments. So a major area of risk is around data integrity and quality, of course. So AI, as we've discussed, needs good data to work with, right? I usually tell my clients bad data in is bad data out. So if the AI tool is learning from untrustworthy or incomplete or even biased information, its conclusions will be flawed as well. So for compliance, you need to ensure that the data flowing into your AI model is pristine, validated, and traceable, focusing on that source of truth, right? And we're seeing, of course, data quality becoming more of the bigger bottleneck for AI adoption in life sciences.
So, it's not just about having data, but about having good, accurate data that AI can rely on. What else should we know about compliance in AI? Like, what impacts does it have?
Oh, sure. Yeah. So AI can impact compliance in both positive and negative ways, of course. So, some positive impacts that can include automation of regulatory monitoring and change management, enhanced risk assessment, and even policy management and training. So, now on the flip side of things, AI has also introduced challenges and negative impacts. So, governments and regulatory agencies are developing AI regulations like the EU AI Act and Canada's AI DA. Companies that are using AI tools must now understand and comply with, requiring a level of AI governance as well.
Are there other challenges that we should be aware of?
Oh, for sure. So transparency and comprehensibility also create problems when we talk about compliance. When making decisions using AI tools, regulators often require transparency and the ability to understand why a decision was made, right? So, but the difficulty comes in when demonstrating compliance, when AI performs these tasks using complex logic and decisions can't be adequately justified, right? So the AI tool does all this special hard work and I can't explain it because I am not that smart and I can't explain that complex logic behind it. So,
That makes perfect sense. Traceability and justification are core tenets of GXP. What about the sensitive nature of the lab data itself, especially when patient information is involved?
Oh, yes. So let's talk about data privacy and security then. Labs often handle highly sensitive information like patient data in clinical trials and genomics testing, um, which falls under strict regulations like HIPAA in the US or GDPR in Europe and various other global data protection laws as well. So integrating AI, especially if it involves cloud processing or external platforms, introduces a new vector of for security risks, right? Like data breaches and data misuse. So labs must ensure that there are robust security measures and strict adherence to privacy regulations to protect this data from cradle to grave.
So, securing the data and ensuring its privacy are non negotiable. Beyond the data itself, how can AI be managed in a lab setting?
Right. So managing AI tools requires sort of strategic integration of systems and well-defined processes to ensure effectiveness, ethics, and of course, compliance overall. So it's not just about the AI tool, it's more the environment that supports that tool, right? So I always recommend establishing a centralized source of truth for your data, like a LIMS, a data lake, or even an electronic lab notebook, just to centralize all your data in one location, so you know it's the truth of everything. Then employ your standardizations where possible, like your naming conventions or terminology that you're using um, throughout your processes. So that way, there's the same lingo going through your systems, and everybody understands it. Then I would define data cleaning routines and data validation procedures as data flows from system to system or from process to process. Um, and of course, define your AI ethics policy. That's number one. Addressing your privacy, your accountability, and your transparency. Then, of course, implementing any rigorous documentation requirements for all AI related activities from data preparation and data monitoring, how you're using it for your metrics, right? So that's where the regulators will be looking for as well. But of course, don't forget, this is critical for all audits and external inspections as well. So don't forget that.
Sounds like developing a completely new set of SOPs just for AI. What about concerns around intellectual property?
Great question. Okay, so IP risks are definitely a significant concern. If you're using public or third-party AI tools, especially generative AI, there's a risk of inadvertently exposing proprietary data, right? Um, Labs need clear policies and secure environments to prevent proprietary research data from being used by the AI tool to train public models or from potentially infringing on existing copyrights. So you have to be super careful about what data you feed into the open AI in the public setting.
Are there any significant differences in how these compliance considerations play out across different industries, say between clinical labs or manufacturing?
hmm Yep. So while the core principles sort of remain with any industry, really, there are nuances because of those differences as well. So for clinical labs, the emphasis on patient data privacy, of course, HIPAA, and diagnostic accuracy is paramount, right? So AI is used for digital photography and diagnostics. That they would face intense scrutiny on validation and maybe explainability, as a misdiagnosis may occur and have immediate sort of patient impact, right? So that's one of the concerns for clinical labs. In manufacturing, which is sort of my bread and butter, I love manufacturing. The focus shifts a bit because it's not patient samples; it's just samples in general for manufacturing. It's heavily processed in validation, consistent data quality control, and ensuring that the AI predictions for things like batch release or fully auditable to meet regulatory standards like 21 CFR Part 11. The GXP requirements are also tailored to the specific industry, but the need for robust AI governance applies across the board.
Wow, this discussion has offered so much clarity, Alex. It's clear that while AI offers immense potential, navigating the compliance landscape is critical for successful and responsible adoption. Alex, there's something we'd like to ask all of our guests when wrapping up on an episode, and that is, what is one key tip or piece of advice you have for our listeners to be truly excellent in AI compliance within their labs?
Okay, so my strongest advice for achieving excellence in AI compliance is to prioritize your data quality and your human oversight from day one, right? So don't view AI as a standalone magic box. View it as an extension of your existing quality system and processes. Invest time and resources in ensuring that your data is clean, it's traceable, and unbiased. And more importantly, empower your lab personnel with training, clear roles, and the authority to validate, monitor, and override any AI outputs when necessary. So remember, it's a tool to use, not an overall arching, big brother to tell you what to do. The human in the loop is your ultimate sort of quality control.
I think that is very valuable advice for our listeners. Thank you so much for sharing your expertise with us today on Decoding the Digital Lab.
Yeah, my pleasure, Megan. Thank you so much. It was a great conversation.
And that is all the time we have for today on Decoding the Digital Lab. If you like this topic and want to hear more about industry trends, please be sure to subscribe to our podcast. And we also have a newsletter that highlights current events on a bi-weekly basis, which you can sign up for at the link below or in the description box.